After the first example on elasticity, I told you that we are going to solve more questions. Now we have example 2. Welcome to Physics Media. We are going to solve this question together. Remember all the expressions that we generated in the previous video, and we are going to apply those expressions in solving this problem. So let's go together. Example 2. This elasticity part 5. That's lovely. A force of 15 newtons stretches a spring to a total length of 30 cm. An additional force of 10 newtons stretches the spring 5 cm further. Find the natural length of the spring. And we're giving options. This UTME in 1994, question number 16. Now, understanding this question is very important, very, very important, because of the question language, the way they configured the statement. If you are not careful, you will mix up these values. You may assign them symbols that are not actually their symbols. Yes, so we must be careful to understand the question. So let's begin. They say a force of 15 newton stretches a spring to a total length. So in other words, try to say it in another form. A force of 15 newton produced a length of 30 cm on a spring. Okay, so if we solve a force F1, what is the value? 15 newton. Gave a length, produced a length L1 of what? 30 cm on a given spring. So a force of 15 newton stretches a spring to a total length, to a length of 30 cm. Now they say an additional force. So what do we mean by an additional force? It means that 15 newton is still hanging on the spring. Then they added extra force of what? 10 newton. So we have this. So we have a force of 15 newton hanging on a spring, right? And it stretches this spring to a length of what? 30 cm. They say additional force. That means to add, it means something was there before. So an additional force of 10 newton. So what is now the second force? It's not 10 newton, because when you add 10 to this, it's going to produce what? 25 newton. Remember, we are still applying our principle of I see. You need to identify, you need to set up. So that's what we are doing now. We are doing identification and setting up to identify the quantities given in the question, and we are trying to represent them using appropriate word, appropriate symbol. So an additional force to the original force. The initial force is 15 newton. So an additional force of 10 newton. You get that now? An additional force of 10 newton. That means the new force, the total new force now is going to be what? 25 newton, because 10 newton was added to the 15 newton that was already hanging on the what? On the spring. I hope that is clear. So the new force now is 25 newton, and it produced an extension. So it stretches the spring 5 cm further. So remember this, the spring already is 30 cm. If he stretched it to 5 cm further, it means that the new length will now be what? 35 cm, because the first force gave us 30 cm length. Now they say when additional force of 10 newton was added to this particular force, we had an extra 5 cm extension on that body. So from 30, extra 5 from 30 will now give us what? 35. So that's how we arrive at this. And they say find the natural length of the spring. Natural length of the spring is the unstretched length. The length when there is no mass hanging on it. And from our equations, we say that we're going to use L sub 0 to represent the natural length. Okay. So we look for all the equations where we have natural length, right? You remember that we have several equations. We have said that E1 is equal to L1 minus L0. E2 is equal to L2 minus L0. Then we also say that F1 over L1 minus L0 is equal to F2 over what? L2 minus L0. We have this. Now L0 appeared in these three equations, but which one will be suitable? If we come here, if we are trying to find this, we don't know E1, so it becomes a problem, and there is no way of finding E1, even though there may still be a way of finding E1, but there is no direct way of finding E1 here now. So we cannot use this equation to find L0 because we don't know what E1. So we are now exploring. Exploration means to search for the suitable equation. So E2, L2 minus this, we are looking for this. Do we know E2? No, we don't. We don't. And we are looking for L0. We only know L2. So this equation cannot also be used. So we cancel these two. So let's check the remaining one and see the possibility of using it. We know F1, right? We know F2. Do we know L1? Yes, we know. Do we know L2? Yes, we know. The only unknown in this equation is L0. So this equation will be suitable for our calculation. So we move. So if we do that, now we're using F1 all upon what? L1 minus L0. So F1 over what? L1 minus L0 equals F2 divided by L2 minus L0. What is F1? 15 Newton divided by, what is L1? L1 is 30 minus L0. What is F2? 25 over what? 35 minus L0. Right? Now, we are not going to change this to meters because already the answers in the option, they are all in centimeter, you see. So don't force yourself saying, oh, let's change it. Okay, so let's move together. Now, if you decide to clear the fraction by means of cross multiplication, you will have very high values here. But I know that if I want to reduce this, I can divide both sides by 5. If I divide both sides by 5, you see, this is a strategy of calculation. Divide both sides by 5. Both sides by 5. So 5 dividing this side, we are going to have 3 here over 30 minus L0. And 5 dividing this, we have 5 over what? 35 minus L0. So you can now clear the fraction, right? So if you can still cross and multiply in your own way, you still arrive at the same answer. But under exam condition, if you have things like this, you have to be very careful. Look for means to reduce the time you will spend in solving the question. So if you clear the fraction, we're going to have what? 3 bracket 35 minus L0 plus what? 5 bracket 30 minus L0. Okay, 3 times this will give us 105. That's what we have. Minus 3 L0. 5 times this is 150 minus 5 L0. Okay, so we now collect like terms. Let's gather like terms. So I'm going to have minus 3 L0 plus 5 L0 plus 150 minus 105. Okay, so that will give us, let's clean this question. So that will give us, this will give me what? 2 L0. And 150 minus this will give me what? 45. Therefore, L0 becomes 45 over 2. L0 will give me what? 22.5 centimeters. So we look for the correct option. The correct option is B. We are not done yet because we need to solve more problems. But before we continue with our calculations, in the next video, we'll be looking at energy stored in an elastic material. After looking at energy stored in an elastic material, remember we still have a lot of things to look at in elasticity. We still have some basic terms to consider, things like stress, strain, tensile force, tensile strain, and the rest of them. So we are going to still look at all of that, Young modulus, and also the graph, the force extension graph. But first, Let's look at what's going to be elasticity part what? 6. See you there.